Yeah, I hear you now. Zaki,
Sir,
I hear you.
do
I
you hear
hear
me?
you. Yes, yes, I hear you.
Okay, okay, sir.
Talk about differences between hydraulics and fluid mechanics. So far, I talked about hydraulics. And what is the main difference between hydraulics and fluid mechanics in your mind?
Uh, Now I don't remember, sir.
This is
I
not
don't know.
I. This is not a question from your memory. Let me ask: Do you when you passed fluid mechanics, when which
Uh,
last semester or 1 year session?
Actually, I passed 1 year ago.
1 year ago. 1 year ago. So
Yes, sir.
definitely you and some students who passed the fluid mechanics 1 year ago, definitely you need to study fluid mechanics again to get familiar with some ideas. Otherwise,
Okay, sir.
you will have some problems during the course. Okay. Erdem Çetintaş. Erdem, open your microphone, please.
Yes, teacher.
How are you, Erdem? I see that your face completely changed with longer hair. You were not
Uh,
like this. Yeah, you have
yes, I
changed.
didn't cut my hair
Yeah, yeah.
for a long time.
This is you are afraid of going to barbershops, maybe, yes? Or you would like to have long hair. Anyway, this is your personal thing. I'm just kidding. Could you talk about differences between hydraulics and fluid mechanics?
Mm, teacher, I
I
have come already just now.
what?
Uh, I joined just now the lecture.
You joined just now. Okay, you don't have any idea about hydraulics. Uh, you you already took and failed, or this is your first time that you
Oh,
take this course?
yes, yes.
You failed already the course?
But I have some microphone problem. I need to took.
Repair it for the next session. Mofia, open your microphone.
Yes,
Let's
Hajj.
continue. How's it going?
That's going good so far.
Very nice. Mufia, are you in Antalya these days or you continue from your hometown?
In Antalya now.
Good. Um, Mufia, you had hydraulics with me already, yes.
Yes, I took it.
It, it it was a summer semester course, maybe, or it was you in one summer you had a course with me. Am I right?
No, Hojam. That was, I believe it was in 2019.
Ah.
Yes.
I remember you never had summer course with me.
No, no, sir.
Okay, so uh, do you have any idea about differences between hydraulics and fluid mechanics?
Okay, I might not be right, but I think maybe for fluid mechanics, they probably focus more on the properties of the actual fluids themselves. And then, like you said in the beginning, for hydraulics, you get to look at the control and the transportation of the fluids that were discussed. So basically, I feel like there's a difference between the management, if that makes sense.
I'm really glad that to see followed me very well and you are able to extract some conclusion from my talks.
Thank
Uh,
you.
It could be. It completely gives sense. It could be. Maybe I can summarize your opinion in that way. Fluid mechanics has more scientific topics, but hydraulics is has or deals with application side of those scientific issues. You are going to give something about this. Am I right? You
Yes.
mentioned some. Okay. So I'm going to add more information about differences. So if you forgot what you talked about, what we studied in, yeah, what we, let me see, just here, I am here, yeah. So actually, one other name for hydraulics study engineering is open channel flow. You can find so many. Let's continue in that way. You can find so many books with this title, Open Channel Flow, which is another name for hydraulics engineering. And the difference between hydraulics engineering and fluid mechanics is a difference between open channel flow and pipe flow. In fluid mechanics, we mostly talked about fluid motion through a pipeline. You remember we were talking about Bernoulli equation, energy losses in pipeline, and the most important characteristics were velocity, pressure, and or z term. You remember distance from baseline, this distance or height of a point in a streamline from our datum. But in open channel flow, as the name brings, as it's clear from the name, open channel is a channel with open condition. You know, there is no closed conduit. This is open. It means that water is in touch with atmospheric pressure. Therefore, the pressure term is not important in open channel flow in hydraulic engineering. When we remove pressure term, I don't mean that. I don't mean that there is no pressure. If you remember, always as a civil engineering, we deal with relative pressures, and here the pressure which we see is only atmospheric pressure. And when we are talking about relative pressure, we always neglect atmospheric pressure. So when we have atmospheric pressure and we remove the pressure term in Bernoulli equation or in general from energy equation, it means that hydraulics engineering could be a bit easier than fluid mechanics. So in addition to the difference that Mofia mentioned, he said fluid mechanics is more scientific than hydraulics. In other words, hydraulics is the application of fluid mechanics for real-world engineering. Okay, this is one difference. The second one, hydraulics deal with open channels like rivers, streams, or canals, man-made canals. There is no pressure term or relative pressure term in the energy in hydraulics. Why? Because in open channels, the pressure is what? The pressure is atmospheric pressure and negligible in relative sense. Okay, these are two differences. Looking at this figure, can you guess any other difference, or can you suggest me any other difference? Compare, we have a river, and in fluid mechanics, I told we are dealing with pipelines. Any difference? So, Shahmuz, Can you put forward some idea about difference? Any other difference? Look
Sir,
at this figure. It gives some clue. Yeah.
the hydraulic engineering generally work on the mechanical properties of the fluids.
Don't go to definitions. You know, it seems that you are reading from somewhere. I'm not looking for definitions. I told you, look at this figure. It says something.
Follow
What?
the flow of the
It says flow,
water.
but what it says? We have flow in both pipeline and natural. It says something. One, first, you see we are talking about atmospheric pressure. It is open. The pipeline is closed. The other thing, can you guess? Can anyone guess any other difference?
I can guess hocam.
Go ahead.
I think fluid mechanics about all fluids. Yeah, I mean gases, water, everything it can be. Yani fluid it can be, but hydraulic is related with water, I guess.
Yeah, who is talking?
Rümeysa hocam.
Rumeysa. Okay.
I don't true, but
No. You are right. You said that we are talking about water. Yes, this is true, but I was not thinking about it. But this is true. Here we have only water in pipeline.
Free surface water.
I talked about it. Free surface means the same thing.
Open
Free
channel.
means open channel, means atmospheric pressure. Here you see this figure talks about friction. Very friction force is seen here. You see, but in a pipeline, the friction is not such significant that you see here. What is the friction? Is something that resists against motion. Yes, you see this pebbles, vegetation. Banks, river banks full of the stones, you know, all are things put some friction, or in engineering language, it increases friction force against motion. But friction, you remember in fluid mechanics, we had Darcy-Weisbach formula, and we have a friction factor Modi diagram, and friction was not a big deal. Of course, it is a big deal for long pipeline, but for a small pipeline, friction was not a big deal unless you had some bends, some valves. Do you remember we had minor and major losses? And minor and major losses. Major losses was those comes from long pipeline. But minor was those originates from some connections, like bend, like a T connection, like a valve in a pipeline. So all those add some friction, which resists against motion or decrease the energy of motion. But for hydraulics, you see friction is very serious problem in hydraulics engineering. And for water motion, we need more energy. Yes, if energy is friction is high, you need more energy to have motion. Am I right? Yes or not? So let's continue with another question. By the way, any answer, positive answer, brings you a positive mark, which will be added for your final score. So try to communicate as much possible as. So I wanted to ask a question from Mehmet Emin Sarkaya. Open your microphone, please.
Yes, teacher.
Okay, Mehmet. You know, I I talked about friction, and I told that if friction force increases, we need for more force in order to have motion. Some force that how should I explain it? We need to increase force in order to have continuous motion of flow. Yes, because in case of look at my hands, this is no friction and water moves. But for higher friction, motion velocity decreases because friction acts against motion. So let's come back to fluid mechanics. What was the source of energy? What was the source of force, energy actually, in order to create motion in a pipeline? Do you remember anything, or can you guess something? Force of energy, source of force, source of energy for motion in pipelines.
Really, I don't understand very well, but you asked me the source of force or source of water?
Source of energy, force, not water. Source of energy. Why water moves in a pipeline? This is some energy. If without energy, no motion. What is the source of energy? What is the main trigger for motion?
Really, I don't know, teacher. Maybe the friction, the energy comes from friction and the movement of water.
In friction energy is again the motion, resists, not in the not the reason for motion. It is not a reason. It resists against motion.
Sir, I can give an idea.
Who is talk?
Emily Asman.
Emily? Okay, talk.
Well, I know that in drainage pipes, they are always constructed so that the water goes down with gravity. So I think that it could be due to gravity.
Emily. Yeah, in drainage, what? In drainage canals, you mean, yes?
Yeah, like for example, drainage pipes that are constructed in a building.
Yep, you are right. But it is not called drainage pipe, okay? Those are water disposal or wastewater disposal pipes. Drainage canals, we have drainage canals in agricultural area. Or for the case of pipe, I've not heard drainage pipe. Anyway, you are right for the case of open channel flow, even within a pipe. I will talk later that we can have open channel flow. You will see we can have open channel flow within a closed conduit, within a pipe. So
Sure.
your answer is true for open channel flow. When I talk about fluid pipelines flow is under pressure. I told you we have pressure term. Under pressure, therefore, the reason you are also right in water disposal system network, pipeline network in our buildings. Every motion is the result of gravity. You are completely right, but this is the case, another example of open channel flow. I will go in details just after several slides. Yes, anyone?
So atmospheric pressure affect pipeline?
Never. I told we have
Maybe
the source of energy in pipeline is some other thing.
maybe for slope.
Who said?
Mehmet Emin.
Mohammed? No. Again, look, a slope is a slope is another terminology for gravity that Emily said. By the way, Emily also got one positive. A slope is nothing than gravity. Yes.
Yes, but
Slope.
it is.
But
It's
in open channel flow, I agree with you. 100% agree. You can take a note. Write this. The main source of energy in open channel flow is gravity or slope. Those, because by slope, gravity both are the same thing. But for the pipelines, you don't remember pumps? Pump. This is one source. You don't remember height of flow at a reservoir? We had a tank at upstream, another tank at up and downstream, a pipeline that connects these two tanks. So there is a pressure up, there is lower energy down, or higher energy, and water moves from higher energy to lower energy. Therefore, the source was the height of water in a tank or so a pump. Actually, I asked this question to get answer. You know, I was expecting that you say, yeah, oh, professor, we have different pumps or turbines in order to increase or decrease energy in pipelines. Yes. So it was the easiest question, but you answered the more complex one, which I was going to ask. What is the source of energy in natural channels? The source of energy is gravity, as Emily said. In natural channels, source of energy is gravity. Therefore, we can say the third difference is source of energy. In pipeline, source of energy is more or less a pump, a reservoir, but in natural channels, in open channels, our source of energy is gravity. Everything is gravity. Water moves as a result of gravity, or as Mohammed Amin said, water moves as a result of difference in the slope. Difference in a slope between 2 points, it moves from upper elevation to lower elevation. It is slope or it is gravity. So we can conclude that we have three main differences. You can also make a note. By the way, your friend started this recording this session. You can came back to watch again this lecture and memorize those three differences, which is an important thing from my mind, in my mind. So one other thing, please never start recording without my permission. If you do it again, definitely will have some problem with me. You might remember my students last year did it, and I completely lived the online teaching. I can do it. I can provide some links, some PDF files like other instructors, and so please never repeat such action. I would like to ask a question actually, but the answers is given. Liquid water, let's continue from here. Liquid water or liquid or water flow with a free surface. It means what? It means that the water surface is in contact with atmospheric pressure. We talked about it. Interface between water and air. It is called water free surface or water surface. Okay, remember, when I talk about free surface, means the surface of water which is in contact, in touch with atmospheric pressure. Relevant for, it means that hydraulics engineering, relevant for, or talks or deal with or talks about natural channels like rivers and stream. Okay, I talked about it. Engineered channels like canals, sewers. Canals are, this is a canal, you see, this is a canal, okay, in order to transfer water for irrigation purposes or even for industrial water supply, for drinking water supply. We built some canals between the dam and between the end user. For example, it can be a water treatment plant or an agricultural area. Then engineered canals, yeah, man-made canals, and sewer. What is a sewer? Sewer is a small or narrow canals we have mostly in urban area in order to collect storm water and drain storm water from cities to the water disposal system or to another river, a bigger channel. And this is engineered channels. And sewer lines or culverts. Sewer lines, the sewer line is a collocation. Sewer lines or culverts, partially full, and storm drain. Storm drain is, as I told, is called sewer, the storm drain network. And culvert, we already talked about culverts. I showed you we have box culverts, circular shape culverts. And culverts are partially full culverts. You see that culverts, you remember I showed you circular culverts. This is a closed channel, yeah, closed conduit, but it is considered open channel. Why? Because it is partially full, not completely full. But in pipeline system, in fluid mechanics, always our pipe is full. We cannot say half of the pipe is full, the other half is empty. So, but culverts is commonly designed that they are partially full in a way that they act as an open channel. Of interest for hydraulic engineers, location of free surface. Yes, you should always know about location of free surface. It's an indication for the water depths. Because we have a bed, and we have a free surface. Bed of the channel, free surface. The distance between two levels gives you depth of flow. This is why the location of free surface is important. Velocity distribution, like fluid mechanics, we are dealing with finding velocity, because velocity is the trigger for discovering in hydraulic engineering. Velocity shows you when a water from upstream will reach to downstream. Therefore, your calculations will be in a direction that you should find velocity or depths or steps discharge. Depths also called stage discharge, stage relation. Stage means the depths, you know. Here you see the stage, water stage in a river means water depths. And optimal channel design. The other thing in hydraulics engineering is these are not relevant to the differences. These are some extra information about what we are going to do as a hydraulic engineer. Optimal design. You know, in order to transfer a given amount of water from upstream to downstream, we can make a big channel. We can make it small and smaller. But in some cases, if it's too small, we will have overtopping. and the capacity is not enough in order to transfer amount of water we need. So optimal design is something that you are dealing with as a hydraulic engineering. Which shape is optimal? Which dimensions? Which slope? Everything should be optimized in order to minimize cost of construction. Optimization, by optimizing, it is a general word. Optimization of the shape, which results to minimizing the cost. Okay. Any questions so far? No. So the classification of flow is the other important things that is the main material for our next lecture of today's session. I mean lecture 2 that we are going to have today. This is only a brief review. Let's only read it, and I explain after a break. Steady and unsteady flow. We have, let's give only the name. When we are dealing with water, flowing water, there are different patterns with respect to the time or with respect to the space. And by considering these patterns, we divide a flow for different categories. One of them is steady and unsteady. What is a steady flow? Steady means something constant, yeah? Yes, steady, stable, constant. When we say the flow is steady, it means that by passing the time in a given section, flow characteristics such as discharge, such as velocity, such as depth remains constant. No variation, no change in those characteristics by the time. For example, you are looking for a river section, and you are calculating. Assume that you are measuring the velocity. Now you measured 1 meter per second. After 10 seconds, 1 meter per second. After 1 hour, 1 meter a second. You see that within this duration, within this small time period, 1 hour time period, the velocity remains constant and it does not change by time. So this is stable. What is unstable? Completely the adverse situation. Unstable means, unsteady means, let's say unstable, but it is not a technical word. Unsteady is the flow condition that flow characteristics. Again, remember it. We have 3 important characteristics in hydraulics: water depth, discharge, water velocity. Actually, discharge is nothing than velocity and depth, you know. Depth is a characteristics of area, and if you multiply it by velocity, it gives you average. If you multiply by average velocity, it gives you discharge. Therefore, we have 2 main characteristics: velocity, discharge, or velocity, elevation, depth. In hydraulics, we use depth. So these 2 characteristics may change by the time in a given section. Therefore, this is unsteady. For the uniform, we have also uniform and non-uniform flow. When we are talking about uniform and non-uniform, we are dealing with distance along the river, along the channel. Okay, we are not looking at a certain point. Okay, we are thinking or looking at a long space along the channel, along the river, along the canal that we are evaluating, or we are interested in knowing what is the flow condition by space, by means along the channel. If everything, I mean flow characteristic, remains constant, but for example, water depth at here is exactly the depth at here. The distance between 2 cross sections, 2 points, 2 measurement locations. Assume that it is 10 meters. We have 1 meter distance here, but this charge here and this charge here, velocity here and velocity here, or depths here and depths here are the same. We have identical characteristics. Therefore, it is uniform flow. Okay, it is uniform flow. But one of them, if one of them changes, for example, assume the top of my fingers shows the elevation, and if I have such, you see such difference, you know, water surface or free surface at upstream, water moves, assume that water moves from left to right. For me, it is left to right. If water moves from left to right and there is a slope at free surface. What does it say? It says you that what? There is a slope. It says you that elevation, water elevation at upstream, or what? Let's say depths, not water depths at upstream is more than water depths at downstream. Assume that we have a horizontal bed, okay, for a horizontal bed. Therefore, it is the case of non-uniform flow. And depend on the variation or type of variation. Is it a sudden decrease or is it a gradually decrease? We say this non-uniform flow can, or it is varied flow. It can be a rapidly varied or gradually. As I told, if a sharp decrease, a sudden decrease, like hydraulic jump, I will show some example at next lecture. It is varied. It is, sorry, rapidly varied. But if the water surface gradually varies, assume that in 10 meters, distance within 10 meters, water surface change 1 centimeter, or let's say 5 centimeter, more sensible. So it is called gradually varied flow. The other category is laminar and turbulent flow. You might be aware of it based on your knowledge of fluid mechanics. Laminar flow is the flow pattern when water layers, we assume that water moves in layers, okay, and each layer moves in a given direction. There is no random random location, or there is no interconnection of motion of water layers, or water, we can say also water molecules, okay? Each layer moves in a given layer constantly along, again, this is along. It is something that we are explaining with respect to a space. If one layer moves in a given direction and don't change its path suddenly, it is laminar. And if the path of water molecules or layers is random and we cannot trace the path, or it is said that irregularly, one molecule moves irregularly. For example, comes from here, then goes up, goes down, came back, a vortex will happen, then moves downward. It is irregular pattern, which we say turbulent flow. Okay, that's all for lecture 1. And if you have a question, I can get some questions. If there is no question, I can give you a 10-minute break, 10 to 15-minute break. Then I have a short lecture about the open channel flow, which is a supplementary lecture for different flow patterns. Any question you have? Okay, so I would like to give you a 15 minutes break. Then please come back to have a short lecture to complete first chapter 7 of our textbook. Okay, see you in 15 minutes. Bye for now.